Good afternoon, everyone. My name is Mesh, and today I will be presenting on the topic Model Serving Architectures, REST versus Streaming, designing efficient AI inference systems, choosing the right AI model serving architecture. RESTful architecture is synchronous request response, and streaming architecture is real-time data flow. What is model serving? In a process of deploying ML models for real-time or batch inference, makes models accessible via APIs and pipelines. Core part of production is AI systems. Why serving architecture matters? It impacts the latency, scalability, and cost. Different use cases require different approaches, and choosing wrong architecture can lead to delays and system overload. The two main approaches are synchronous serving, that is REST APIs, and asynchronous or streaming serving. The key difference is response timing and data flow. Synchronous serving, the client must wait for a response. It is a traditional request response cycle and sequential data transfer, that is, data sent and received in distinct steps. For asynchronous serving, it is when the client can continue processing without waiting, which enables a continuous data flow, and flexible and continuous data flow, the data can be processed as it arrives. So for synchronous serving is client sends a request and waits for response. Common tools are fast API and model servers. The example is Triton. It is used for a real-time inference. The flow is client, then it goes to API, then it goes to the model, and it waits for the response. Advantages of REST serving is simplicity. It is easy to understand and implement for developers. Immediacy provides instant responses for real-time applications. And low latency. It is ideal for applications requiring quick data processing. For debugging and monitoring, it facilitates efficient troubleshooting and system oversight. Limitations of REST serving. High throughput REST serving is not suitable for high volume data processing, long running tasks. REST serving is inefficient for extended computational processes. Blocking REST serving can lead to system unresponsiveness and scalability issues. Is REST serving faces challenges in scaling under heavy demand. Asynchronous or streaming serving. Client sends request but does not wait. Processing happens in the background. It uses message queues or streams. Examples are Kafka, Pub, or subsystems. Streaming architecture flow. First, the producer, then it sends to message queue, then the consumer model, and then it receives the output. The steps are producer. It sends data or events, the user request, logs, etc. Message queue buffers and distributes messages. It decouples producer and consumer. Consumer, a model service. It processes messages asynchronously and runs inference on incoming data. Output layer then stores the results or sends downstream. Advantages of streaming. High scalability. It adapts to growing data demands without performance loss. High data volume. Processes substantial datasets in real time. Fault tolerance. Continuous operation despite system failures, and event-driven systems enables responsive application reacting to data events. Limitations of streaming. Higher complexity, delayed responses, harder debugging, and it requires infrastructure setup. So let's look at the comparison between REST versus streaming. First aspect is response. It is immediate in REST. For streaming, it is delayed. Then complexity, it is low for REST and high for streaming. Scalability is moderate and high for streaming, and use case for real-time REST and streaming is high throughput. When to use what? Use REST when real-time response needed and low to moderate traffic, and use streaming when high data volume, event-driven systems, and batch or async processing is required. The key takeaways are streaming serving, scalable and robust model serving, REST serving, simple and real-time model serving, and latency versus throughput is the trade-off between response speed and data volume.